K-means clustering algorithm in Navure. K-means is a computational efficiency clustering algorithm that groups data points into K clusters by iteratively assigning them to the nearest centroid, calculated as the average of the points in each cluster. This process is repeated until convergence is reached. We will illustrate the application of K-means to a data named satellite NC, which is located in the test data repository. It contains the reads in 4 bands of 8,572 pixels of a satellite image. Once the data file is open, click the Multivariate tab and click the K-means button. Select all variables and drag and drop them into the Traits panel. The algorithm allows for grouping factors. In this example, we don't have a grouping factor, but if we did, all observations that belong to the same class defined by the grouping factors would be summarized before entering the analysis. In this scenario, the instances that are grouped are the classes defined by the grouping factors. Now click the blue play arrow. A dialog appears. It has 2 panels. The left one is dimmed because we didn't specify any grouping factor. It contains a list of possible ways to summarize the observations of each class, defined by the grouping factors. By default, the summary is the mean. In the panel on the right, there are several options. If Show Plot Q versus K is checked, Generate Sequence is checked, and the number of clusters is greater than 2, a graphical output is shown in the report. It is used to help the user decide how many natural groups there are in the data set. The graph describes how Q, a measure of the heterogeneity within the clusters, decreases as the number of clusters, K, increases. When Save Classification is checked, a new column is added to the dataset containing the cluster number to which each data point has been assigned. If Standardize is checked, each variable entering the analysis will be standardized. Do not uncheck this option unless you want the scale of each variable to act as a weighting factor during classification. If Generate Sequence is checked and the number of clusters is greater than 2, the algorithm will generate classifications for 2, 3, and so on until the specified number of clusters is reached. Finally, a word about starting positions. The K-means algorithm starts with a guess of K randomly selected initial centroids. Then iterate to minimize a target objective until convergence. However, the result can change depending on the starting guess. By default, the implemented algorithm starts from 5 different guesses and chooses the one that minimizes the objective function. If we don't know how many clusters we want to create, but we prefer a data-driven decision, we will ask to create from 2 to a large number of clusters, but not that many. Say 10. To do this, we simply change the number of clusters to 10 and leave the Generate Sequence option checked. Now let's proceed with the OK button. The algorithm is very efficient, and after a few seconds we have the output. The most important result is the chart showing how Q decreases with the number of clusters, K. You can see a rapid decrease from K equals 2 to K equals 4 and then a change, to a lower rate, in the decay of Q. In a case like this, we will suggest that there are 4 natural groups in the data. If we go back to the data table, we will see that several new columns have been added, named K2 through K10. The one we are interested in is K4, since we have decided that there are 4 natural groups in the data. We can quickly visualize how many data points the groups we found contain by clicking the Frequency Table button on the Univariate tab, selecting K4 as the variable we want to tabulate, clicking the blue play arrow, checking Create Classes for unique numerical values, and clicking the OK button. A frequency table and a simple graph are displayed. We can see that cluster number 4 accounts for 54% of the pixels, followed by cluster number 1 with almost 30%. If you go to the Graphics tab, you will find the original chart that was added to the report. Sometimes it may be useful to arrange the bars in increasing or decreasing order. To do that, click the X-axis tab in the top of the window, then click the Sort button, click the descending icon at the top right corner of the dialog and then click OK. The bars are now in decreasing order. You can extend the analysis to describe the average profile of the clusters, and so on.